Rijntje.
Kom maar, dan ga je kapot. Alles is op pad. Ga ik goed zitten. Nu de quiz doen. Wat? Nee.
Ah, dat dacht ik dat jij dat deed.
Ik krijg wel al zijn telefoon.
Ah, dit is een ander verhaal.
Ready to go?
We zijn live.
Yes.
Wat het maar vinden.
Nee jongens, ik ben huis.
Een uur later. 5 dagen. Waarom alleen op vrijdag?
7 dagen.
Ja.
Gaan we wel gaan met...
We zijn compleet.
Ja? Mooi.
Hallo allemaal en hartelijk welkom bij de Ode aan de Code nummer 8 van de internet jongens. Vandaag krijgen we een talk van Michiel Rook. Rook.
Ja.
Met als onderwerp I deploy on Friday. En daar gaat hij ons meer over vertellen waarom hij dat doet.
Ja.
En hierbij geef ik het woord aan Michiel. Heel veel plezier allemaal.
Dankjewel. Ik zag op de meetuppagina dat er een verzoek was om het in het Engels te doen. Is dat verzoek nog steeds geldig?
Moet ik het Engels vragen?
Yeah, no problem at all. The slides are in English anyway, so that's not a problem. Okay, good night, everybody. I'm Michiel Rook. I'm a freelance consultant, freelance continuous delivery and DevOps coach. Live in Utrecht, not that far away. And this talk is mostly about web environments, which at least the internet humans are in, and the rest of you, are you in a web environment or embedded systems or desktop software maybe? All web? Cool. Then this all applies to you. This talk is, it's a Thursday, but it's about deploying on a Friday. And I heard you say it used to be that we weren't allowed to deploy on a Friday. Well, when I talk about deploying on a Friday, there's a couple of reactions that I typically get, and one of them is that people start asking me, deploying on a Friday, are you fucking nuts? The memes are, you just have to search online, there's a bunch of them. Deploy to production. If you do that, I will find you and kill you. If you do that at 5, especially on a Friday, sure, it will bomb. And somebody's going to have to clean up the mess. So what if I just no, just don't. So the memes are there, and like any good meme, they have their source or history in reality, in something of a substance. The memes are. Let's zoom in on why these memes exist. Why does this this hesitance to deploy on a Friday exist? There's a couple of factors that I want to talk about. The first one is risk. So I've seen many companies that deploy a few times per year. For example, the Dutch National Police on some of its systems, and I'm not sure if it's still going on, but they used to deploy on some of their systems twice a year, so every 6 months. Because they thought that this would make the risk of the deployment smaller. And this is a paradox, right? Typically when people say to me, I have a release cycle of 6 months and I do 2 releases per year, then I say, no, you do at least 4 per year. Because typically they do the actual release, you know, the planned one, the big announcement, and then the, oh shit, hotfix. And so that's one part of it. And it's interesting to see that companies, because they are risk averse, and this is a human reaction, right? When we're confronted with lack of information, with lack of control, with lack of things to tweak, our response is to try to get more information, try to impose more control, a stricter regime. to control that risk. So rather than speeding things up, we're trying to slow things down so that we can still think about it, that we can still reason about it. So, and the risk is one big part of it. Control, like I said, is another big part of it, especially in management that is used to talking in terms of loss of revenue. So if we do a release that fails, it's going to cost us this much money. So we better make damn sure that it works, and we don't want to do it too much, because if every release comes out at €1 million, I'm just saying a number, then why the hell would we want to do more releases per year? It's going to cost us more. So the reaction is to actually reduce the frequency rather than increase. Another one is confidence and trust. Confidence in ourselves, in our teams, but mostly in our systems. Like if I deploy on a Friday, especially on a Friday afternoon, then I'm going to screw somebody's weekend. I heard you say something like that just now, right? So I'm going to screw up somebody's weekend, which to me is an indication that, well, you trust your system to such a degree that you know it's going to fail. Meaning you don't really trust your system. You don't really trust your change to the system or the changes that your colleagues are doing to the system. So the response would then be, don't touch it. You know, if it's working, don't break it or don't touch it. So confidence and trust, confidence in our system, trust in each other. And the time to repair or time to recover. Typically, traditional old school thinking thinks of mean time between failures, right? This is probably a number that you've heard when we were talking about hard drives, for example. This hard drive has a mean time between failure of 200,000 hours, which means that on average, or in the median, these hard drives will fail after 200,000 hours. Some will fail sooner, some will fail later, but typically they fail around that time. And the traditional management thinking is to increase that window. And when we translate that to software development, we're trying to make the time between outages as long as possible, rather than focusing on fixing an outage as fast as possible. And what you see in heavy legacy systems where people are very hesitant to deploy on a Friday or hell even on a Thursday, the time to repair is significant. It's measured in days, sometimes even weeks. Systems that go down will incur such a cost and such a load on people to fix it that, okay, if I break something on a Friday, then yes, the weekend will be screwed up because it's going to cost us 3 or 4 days to repair the system. So all these factors are part of what drives the don't deploy on a Friday mantra. And the last one is actually people on call. So I don't want to screw my on-call buddy, or maybe I'm on call myself. So if I deploy something on a Friday night or Friday afternoon, then it's my weekend. And I've been called or woken up 3 times this week already, so please not. So on-call stress is definitely a thing, there goes the weekend. So with all these factors, it's very understandable that people say, don't ever deploy on a Friday when you're working here. And you know, the funny thing is, I used to say the exact same thing. I used to say this, like, please don't do that because it's going to screw up my weekend. And I like my weekends just as much as anybody else. Hell, I like my evenings. But let's consider bugs for a moment. What if you have a critical issue in your system? Would you then be flexible with that rule? So we have a serious security incident. And we need to fix that today. And oh, today is Friday. What about 3 p.m. on a Friday? Is that okay? Well, if 5 p.m. is not okay, is 3 p.m. okay? But what about Thursday? If I think my Sunday is going to be screwed over because I deploy on a Friday, then if I deploy on a Thursday, my Saturday is going to get screwed over. So maybe I should stop deploying on a Thursday. And maybe I should freeze actually on a Tuesday So that we have the Wednesday and the Thursday to fix whatever we broke on the Tuesday, and then we have the Friday to kind of, get back to ourselves. So if we don't do this, let's look at it from another way. Friday is 20% of the week. And this is a significant loss in terms of speed and business value that we can deliver or cannot deliver if we don't release anything on Friday, especially if your competitor is doing that. So my idea is that people that still say this, and all the others as well, of course, but we need to improve. And how do we improve that? Well, by doing it more often. If it hurts, do it more often. This is not something you'll find your local doctor saying, "Well, doctor, I hurt my knee." Sure, go bang it again. It will hurt less the more and more you do it. But translated to our industry, to development, this is definitely a thing. Because if we do big steps, they fail big. That's the only way that a big step can fail. We don't eat an elephant all at once. How do we eat an elephant? Bite by bite. So small steps fail small. And that makes our cost to fail a lot less. And it makes us more versatile and more agile in switching directions if we need to. And the funny thing is, this dramatically reduces risk rather than increases it. And there's a nice graph that I found on Twitter a month or two ago. This graph shows a infrequent release schedule on the left and a frequent release schedule on the right. And what you see is cost goes up linearly, assuming that we have the same development team and they don't get a raise. So this is the cost that we're paying our hosting, we're paying our people, et cetera, and week over week, that cost simply goes up linearly. And if we have a release like here and there, then all of a sudden we add value. What we built is now released into the wild and is usable, so we now have a return. But in this shaded area, that's the risk. Because we are building things where essentially we're building up inventory. If you're looking at a traditional business which sells physical products, we're building up inventory here, but we're not selling anything yet. And then all of a sudden we release all that inventory into the wild, and maybe this is going to work, maybe not. But we're releasing some value. And if we reduce or increase the frequency of releases, we have a lot less risk per little step, and we release that value to the wild a lot quicker. So to me, this is one of the best graphs describing why small steps deliver. And it also means that we need to think of in a different way about the things that we do. And who here still works in projects? Okay. Who here works on products? Cool. So continuous everything is all about the product or project versus product mentality. So projects have, depending on who you ask, a fixed end date. A product has a life cycle. And a product is improved from day one by the same team, by the same people, doing small things on a product that they're building up, rather than a project which they're seeing through to the end, and then the project gets shelved or the team gets disbanded depending on the company you're in. And teams getting disbanded, yes, that's an actual thing in Dutch companies. Take the Dutch railways, for example. That happens over there. And this is a significant loss in knowledge and workability on the product. So we're going from a project mentality to a product mentality. Because only then can we do small steps that iteratively build up that product. The first part of this whole thing, the continuous everything lifestyle, if you will, is continuous integration. And continuous integration is a term that's been around for a significant number of years. Coined by, amongst others, Martin Fowler. And he talks about how a developer on their machine checks in some code to a version control system. Git, Mercurial, SVN, CVS for the really old people, But they check in some code, and a process on a service starts running and builds that code and tests it. Depending on the language or the framework you're in, it may be a compiler, it may be other things that are going on, but it will build and then test the code. And that's where our continuous integration, where CI stops. Because at the end of this run, if everything is green, so if the test passed and the build was okay, the compilation succeeded, then you have an artifact. An artifact which you can store somewhere and maybe deploy at some point. But that's where CI stops. What CI also says is that as developers, we need to integrate with each other at least daily. And this is a key thing, at least daily. And this means that we do not integrate the work of others into our work. No, we integrate our work in that of others. And that's a subtle but very important distinction. So we integrate our work, and I'll come back to that in a little bit, into the main line of development, rather than the main line with us. Because CI says only if you integrate at least daily can you see whether your changes work effectively together with the changes of your colleagues. Then we build on to continuous delivery. Continuous delivery takes the artifact that we built on the testing stage or the build stage and deploys that to an acceptance or a staging environment. And continuous delivery always also says that the code should always be in a releasable state. That's one of the key things in continuous delivery principles. What does that mean? Well, we deploy always to acceptance, but deploying to production, that's a human trigger. So we may have an actual physical button somewhere that we get to press, and then we deploy to production. Now, the deployment should be automated as much as possible, because it should be repeatable. Because well, whoever role I want to be, I should be able to walk into a team room and say, I want this released right now. And the code should be in a state where that can happen. Rather than, no, we need at least 5 hours to roll this and test that and migrate such. No, it should be releasable immediately. Whether we do that, that's a choice in continuous delivery. But it should always be releasable. Now then, building on to the final stage, if you will, that is continuous deployment. And continuous deployment takes the same artifact that was successfully deployed into acceptance, and if all the checks pass on acceptance, it is automatically and immediately deployed to production. So there's no human involvement anymore, there's no human pressing a button or a trigger. This happens automatically. So all the checks are automated, or should be automated. So the key thing behind this whole idea is that we deliver value to users safely and quickly and in a sustainable way. This is the whole idea behind the continuous delivery movement. And the reasons why this is working is if you look at the State of DevOps report or the Accelerate book by Gene Kim and Nicole Forsgren, for example, they did a lot of research on a lot of development teams basically in the world. And they found that high-performing teams deploy 46 times more often than low-performing teams. And what's very interesting is that their mean time to recover is almost 100 times better. So we're thinking in terms of minutes or hours to recover a failed system rather than weeks. And also their change failure rate is about 1/5 as likely as a low-performing team. So even if they have a faster time to recover, they also have a lower failure rate. And this is actual research that shows this. Very interesting. Now, the key part about continuous delivery, or one of the key parts I would say, technically at least, is automation. Automation, automation. Automate whatever's required, not everything. We're not, well, I sometimes say I'm trying to automate myself out of a job. 15 years down the line, that still hasn't happened, but hey, I keep trying. I keep finding other things to automate. But this is a key part of continuous delivery. Now, when we talk about continuous delivery and applying that on an existing project, there's especially like not, or deploying on a Friday, being able to deploy on a Friday, some of the comments I've heard are the following. Our code is old. Our code is not under test. Who's dealing with a system where the tests are, if they exist, flaky, and maybe not even, oh, hello. Good morning. Yes. Our code is not under test. Our code is impossible to change. Yes? Yeah. I've been there, so I'm totally feeling it. So let's take a look at a few strategies to deal with legacy systems, where legacy is intentionally quoted because legacy is not all that bad. It's a system that's hopefully earning money. So at least it's doing something right. It may be our daily nightmare, but it's doing something right. I've dealt with, or I'm dealing with legacy systems that are capable of earning millions per day, but they're still shitty systems. But okay, they earn money. So, you know, legacy quoted. Anyway, the strangler pattern. The strangler pattern, also coined by Martin Fowler, that man really set up our industry with a few interesting terms. He described it as a tree, and I think it grows as a mangrove, or a tree in a mangrove forest. And what's interesting about this tree is it grows on another tree, and it's essentially a parasite. And so, while it grows on the tree, it grows outside of that tree, and basically it envelops it at some point. And then the host tree is no longer capable of sustaining its own life and dies. This is exactly what we're going to try to do with a legacy system. The legacy system, typically a monolithic application with a database connected to the internet, especially because we're all in web. So let's see. Then we add the parasite. And the parasite is initially a proxy between the internet and the monolith, and it's transparent, so it doesn't do anything. It just passes the traffic back and forth. And what we then do is start adding a service. And I'm intentionally not saying microservice here because I don't really care about the microservice movement to that degree that everything should be micro. No, maybe it is aligned to the size of the team. Doesn't really matter. It should be small enough. We start implementing some functionality in that service, and then we add a rule to the proxy right there. And for example, on a page level, or on a host level, doesn't really matter, that forwards that traffic not to the monolith, but to the service. So a little bit of the traffic that is that originally went into our monolith is now being handled by that service. And then we start adding more functionality and services around the monolith, and at some point the monolith itself may even become one of those services, or it may become an empty shell. But all those services will start implementing functionality that previously was part of the monolith. And so the proxy then becomes, has a lot more rules that forwards that traffic to all those services. And they may have their own storage backends and Elasticsearch backends and what have you. But at some point the monolith is either an empty shell and can be discarded, can be thrown away, or it has become a service on the same level as the other services. And so this is the strangler pattern, and I've used this in production quite successfully on a legacy system which was impossible to change and not under test, where we basically bit by bit carved out the pieces of the monolith. Another pattern, if you cannot get away with a proxy or it's too deep inside your code, is called branching by abstraction. And branching by abstraction is essentially a programming pattern. What branching by abstraction means is, let's assume we have an old module, an old code module inside our system, and there's a bunch of client code dependent on it. Multiple pieces of code inside our system are dependent on that old module. So we cannot easily change that old module. And this probably sounds familiar to a lot of people. We cannot, you know, it's like I pull up a little brick in the front yard and the shed in my backyard falls over. This is essentially what this is. right? I cannot change something easily without everything falling over. So what we do instead is we add an abstraction layer. And you can think of that in terms of an interface, for example. And the interface has a stable description, stable specification, and we put that in front of the old module. And basically it's like putting a facade in front of your house. All of a sudden it looks like a different house from the outside, even though behind the facade it's still the same thing. But we're now going to make our clients connect to that abstraction layer, right? So one by one, we're going to switch those clients over to the abstraction layer, and the other clients that still connect to the old module will not notice a thing because the old module is not changing. And then at some point, all the clients are connected to this abstraction layer. And so they're now connected to the stable interface, which is testable because it's built new. So we can, we can enforce certain standards here. And so the old module is now abstracted away behind that layer. And what we can then do is build a new module, which is either behind the same version of an abstraction layer, but better yet, implements the abstraction layer. So the clients will actually not know that behind the abstraction layer, there's something else now. Because they're talking to the abstraction layer. That's their version, or that's their view on the world. That's their reference to the world, right? So we can replace, at will, whatever is behind that abstraction layer. And of course, we replace it with something that's squeaky clean and testable. And at some point, all the clients are now connected, hopefully through simple configuration changes, to this new module. And then the old module can be thrown away. So these two patterns, thrown away. So these two patterns are some of the patterns that are incredibly useful in dealing with large legacy applications, where simply building up a new system alongside it is too complicated and too damn risky. Because what happens if we have a legacy system and we want to rewrite it completely? We rewrite everything, including the bugs, which, especially on a legacy system that's been around for a while, have actually turned into features. People have learned how to work around the kinks in the system, and they expect the kinks in the system to be there. So if from day 1 to 2, all of a sudden all the bugs disappear, to them, that's new bugs, right? Because they've learned to use the system like that. Plus, on large legacy systems, we talked about that briefly over dinner just now. Nobody works, well nobody, not a lot of people work their entire lives at one company. That used to be the case for a lot of people, but these days it's far more common to see people switching after a number of years. So what you see is that there's nobody in the company that completely knows the system inside and out. So knowledge moves out of the building, and not every decision was recorded, and some things simply get lost in time. And so if you build a system B, which is supposed to mimic system A completely, then the only thing that's going to happen is it's going to fail. So these two patterns will allow you to do that in small steps. And like we saw, small steps give a far better chance of success. So, on branches, another interesting topic. I talked about continuous integration, saying integrate at least daily. This also has a consequence for using branches, especially long-lived branches. Long-lived branches can give conflicts. Who here has ever had a merge conflict? Who here has ever had a serious merge conflict? Who here has ever had a merge conflict resolve and then all of a sudden old stuff starts to appear? Yes, we've all been there. We don't have to be bigger or pretend that we don't. So this is an actual statement from one of my clients. I'm not going to say who. And this is a relatively benign one. You may have seen this picture. And this is, quite honestly, quite easy to generate. But what do these things say? Especially when you look at it from a CI point of view. what they all do is delay integration. So long-lived branches delay integration with the rest of your colleagues. Yes, you may, in branch terms, you may merge master if you're on Git to your branch, but you're not integrating your work with the others. You're still not seeing all the work of the others, because you are not going to merge in master plus all the other branches that are open at that time, because that would be merging, that would be integrating with your colleagues. That would make your life quite interesting, to say the least, and you probably would not get around to doing a lot of development. So there are a few branching strategies that I want to discuss with you tonight. And the first one is don't. And the second one is, well, don't. And the third one is also don't. This is blatantly stolen from Dave Farley, the author of, or one of the authors of the Continuous Delivery book. And typically when I say this, you're very kind to me, but typically when I say this, something like this happens. I may not get thrown out of the building just yet, but this is all about trunk-based development. And like the name says, this is an older style of working. Because what refers to trunk? Do you know which version control system?
SVI?
Yeah, and there's one before that? Yeah, CVS. Git refers to it as master. And like extreme programming, which by this day and age is 18 or 19 years old, trunk-based development was actually the standard before Subversion and Git came along. Because some of you may remember the interesting days of Subversion and branches and merging. I've seen many repositories go completely bonkers on a branch merge in Subversion. And then Git came along. And all of a sudden, branches became cheap and easy and first-class citizens. And then came Git Flow and all of the things associated with branches. And all of a sudden, you see the branching model with a lot of companies go completely upside down and go from trunk-based to completely feature branch-based. And this is new. This is relatively new, at least. Git has not been around for that long compared to the other version control systems. Now, if you look, for example, at Google, Google's been doing trunk-based development completely and entirely since its inception. And they've not deviated from that. There's a simple rule: if you don't like trunk-based development, you're not a Googler. That's essentially pretty black and white, but that's what they do. Then there's a question, what about short-lived feature branches? Are they okay? Well, if we go back to CI, saying integrate at least daily, then a short-lived feature branch, the short-livedness should be less than a day. Because otherwise we don't get to integrate daily. And then my question is, if you have a feature branch which is not alive for more than a few hours, what's the use of the feature branch? Why use feature branches at all? There is another topic, and that is the pull request. Who uses pull requests here? Okay, for reviews? Yes? Awesome, because, whoop, there goes my joke. Pull requests are used for code reviews, typically. And that is all fine and all good. And if you didn't do code reviews before you did pull requests and you're now doing code reviews, that's definitely better than doing no code reviews. But there's one big issue with code reviews in a pull request scenario is that they induce flow delay. And what do I mean by that? There's a single developer developing something, they are done, submit a pull request, and then somebody else needs to review that. And they get pulled from their context. Depending on what your rules are, how quick or how slow people should respond. If there are no rules, then people don't respond. Not when you want them at least, and your pull request ages and ages and ages. And I've seen this happen at many, and you're seeing it happen as well, I think, yes? So, you see some companies imposing a rule. If there's a pull request, somebody needs to deal with that in X minutes after it's submitted. And that means yanking somebody out of their context. They're working on something completely different. Hell, they may even be working on a different service or piece of technology. And they're yanked out of their context, and they need to deal with that pull request. And then they look at the pull request, depending on the amount of energy, time, and the amount of lines in the pull request. It may be an actual review, or it may be a looks good to me type review. Research has shown that after a certain amount of lines, people will do that, because they simply, they see a book, and I'm not ever going to get through that, looks good to me. I don't see any obvious errors. Yes, merge. Yeah. And so the only way of dealing with that is keeping pull requests as small as possible. 10, 20, 50 lines tops. So with all these aspects, all these negativity about pull requests, you saw the picture already, there's one answer, and that is pair programming. Maybe not like that. But what pair programming does is it serves as a knowledge transfer between people. This is especially useful for employees that just joined the company versus the seasoned employee, juniors, seniors, etc. I typically do not enforce this, but I encourage, because it does lead to a lot better quality, significantly better quality. It can wear people out, though. That is something to be mindful of. Not many people are capable of doing pair programming 8 hours straight. So you need to be aware of that. But it does lead to better software. And it gives you a continuous and inline code review, rather than asynchronous flow delayed code review. It's also a better quality code review. Because one other thing that you don't see in the pull request, you only see the product of the reasoning. You never see the reasoning. You only see the code. And more importantly, you don't see the code that was not written. And you don't see the reasoning behind why that code was not written. Whereas if you do pair programming, you're continuously talking with each other and discussing and verbalizing what you think and why this code should or should not be written. And there's another way of doing that, another approach, and that's mock programming. And this is actually, I've done it a few times, not nearly enough, but what I've seen is that, yes, like pair programming, it wears people out because it requires you to be switched on, essentially. So you need to be able, as a person, to rotate in and out depending on what you're capable of. But this is a very interesting way of doing that, and there is some research online, well, it's not actually research, it's practice, of a team, I think in Sweden, that's started out mock programming from day one, and they do it every day. It's an entire team that does nothing but mock programming. And yes, there are a few kinks, and there are a few lessons to be learned, but overall, they are very happy with how that worked out. So it may be worth an experiment, you know, get the team together and try this for a few days. When it comes to feature branches, there's another reason that feature branches are used, and that is timing. Like I want to have this feature live at date X, and then we merge right before date X. So merging features in time. Now there's also a more interesting way of doing that, and that is we want to decouple the deployment from the release. The deployment being the technical thing and the release being the functional thing. Releasing functionality into the wild versus technically deploying software to a machine. And that introduces the terminology feature toggle, feature switch, feature flag. You may have heard about this. And the feature flag essentially is an on and off switch in its most basic form that turns a particular piece of code on or off for a certain group of users. And conceptually, it's an if statement, where the expression in the if is whether the feature flag is on or off. It's very simple. And on an actual site from a few years ago, this was the old version of the site, where a search page for jobs in the Netherlands, and the right page is the new version. This ran on Solar, that ran on Elasticsearch. So not only did we do a complete styling change, but there's also a complete backend overhaul. This is not something that you do in a few commits. This is not something that you do in a few days. This took about a month and a half, something like that, the entire architecting of it. And what we did is not hold deployments for a month and a have a single release or deploy after those days. No, we started deploying from day one, but behind a feature flag. And then at some point we thought, okay, now the design is worked out enough and we've seen enough working locally that we want to switch the feature flag on for the local office, so for our local IP range. And then we got a bunch of feedback, and then we had the feature flag at 10%, which basically means that 10% of web traffic is going to see that version, and the other one is going to see that version. Now this is the old application which we wanted to get rid of, so we stated that if this, the metrics for this page are at least as good as this one, then we consider them better. And this was, well, 25 to 30% better than that one. So it was easy. Then we went up to 50%, see whether that would still hold, and then to 100%, and then we started removing all the old search code. So this allows us to completely or continuously deploy code to production and have it fully tested, but essentially dormant. It's essentially sleeping on your production machines. And then, depending on the state of your feature toggle, it'll be working or not. One thing to keep in mind though is feature toggle debt. If you have too many feature toggles in your system, they can lead to a combinatorial explosion of possible paths through the code. So you need to be aware of that list and keep it as short as possible. All right, slowly working through to the end of the talk, I want to talk a little bit about build pipelines or pipelines in general. And like the factory, like a car factory, they take small products and ingredients and build onto something more, and then finally a car, which in our case would be software in production. And the pipeline starts with checking out code, compiling, depending on your language, testing, packaging, and then deploying to acceptance if it's still viable, verifying, deploying to production, and then verifying again. I've seen companies get rid of the acceptance stage completely. Because if your testing stage on this end is good enough, then maybe you don't need a staging environment. But that is up to your use case. The testing though, continues as well. And there are a few things, there are many more things you could test, but these are some of the potential testing layers. The unit test level we all know and love, or hate, or loathe, or want. Then the integration test level, where we actually test components and their interactions and potentially test against an actual database where we insert data that we have under control, data fixtures. So that we can then verify whether a thing that deals with those fixtures returns a value that we expected. Acceptance tests, in the given, when, then, and Gherkin style of writing tests. This is for the PHPers amongst us. You can look at bhat, for example, or PHP spec does something like this. Cucumber in Java, where we talk about, we write essentially in plain English or Dutch, if you want, how functionality should be, how functionality should work. And then there's the end-to-end testing stage, which is typically written in terms of Selenium or other tests. So we actually fake a browser or open a browser and click things in the browser and verify the application as the user sees it. Now, this last stage is somewhat problematic because it is by its definition slow and typically brittle, because depending on how you write the Selenium tests, if you change the name of a button, then the test will fail already, even though the button is still there. So they're kind of brittle. And what you also see is that people abuse end-to-end tests because they think that their system can only be tested by end-to-end tests, because the argument is then, if a consumer sees the error in like the top layer of the application, then we need to test it there, even though the actual error occurred far below in the backend somewhere. Now, I recently read an interesting line about end-to-end testing, and that is, who here is aware of the term contract testing? A few. So the contract test is when you're talking about APIs, there is a contract between APIs. So an API exposes an endpoint, and that endpoint gets input and produces output typically. And the way it takes input and the way it produces output, that is part of a contract. That is part of the specification. And that contract can be tested, or rather, we can test whether the API matches the contract. And think of it in, so when we test APIs, we don't test the entire chain. We, ideally, if we want to test one service which calls another service, we don't want to have those both services running to test the first service. Right? Imagine if you have a smoke alarm at home, and the only way to test it is to set your house on fire. This is typically not what we do. At least I try to avoid it. So this is why I buy smoke alarms with a little button which you test once a year or twice a year. This is a contract test. We actually test the contract that we have agreed on with the smoke alarm, that it's going to react, so we test the circuit of the smoke alarm. We don't actually test the whole thing, because when we test the circuit, that's our contract with the smoke alarm. That's what we test. Cooking. Cooking, yeah. Cooking is, that's an actual end-to-end test. Yes. We also try to avoid that. Yeah. So, looking at all these testing layers, there may be a thing there's a thing you may be aware of, and that is called the testing pyramid, which in some companies is upside down, or we call it the ice cream, the testing ice cream cone. But this is a typical, or this is a testing pyramid that we should strive to have. I'm not going to go into numbers here, because they're not interesting. Roughly, this is the shape that you want to go for. And why? Well, as you go up in the pyramid, cost increases. And as you go down in the pyramid, speed increases. So unit tests are at the bottom because they are, of course, they are the most numerous, but they're the fastest and the easiest to maintain. So they cost less to maintain. Integration tests, because they require maybe an actual database and fixtures, they are slower and more costly to maintain. And end-to-end tests are the most costly to maintain because they're so brittle and they run slowly. So their speed is not as good as a unit test, which is why we want to have a few of them, but definitely not too much. Then there's also two oft overlooked parts of testing, and that is exploratory testing and user feedback. So if you have a user feedback form that gets information, your site is not working anymore, please fix it. That's testing as well. Exploratory testing, where your QA people will go through production from time to time and verify whether all the cases are still covered, whether some tests can go away, for example, or test cases need to be rewritten. And then there's monitoring and alerting, because not everything can be tested and not everything shows up in the test. Some things only show up under load or stress, or at some parts of the night, or during a summer-winter time switchover, for example. So you want to have an alerting system to alert you to, elevated error rates in your application. And this is definitely a part of testing as well, even though people think it's not. But testing, a test suite should, good enough is good enough, because we can test everything and anything, and then the guarantee is that our pipeline will take hours and hours to run, at which point people will start to ignore it or match speed. Both are equally suboptimal. So pipeline speed is key. No test suite detects every issue. That is also something you need to be aware of. And what's interesting, I talked about that with a tester 2 days ago, and they said, people have a hard time letting go. How often do you clean your house and actually throw stuff away? Or they go, this cable, I may be able to use that at some point, and put it in a box. And then we'll put the box in the box, and then we'll put the box in the attic, and at some point it will go into the garage, and we're all hoarders in a sense. And with tests, this occurs as well. We're incredibly hesitant to throw away tests. Because, yeah, who knows what this test does, you know, it may be useful. And if we throw this test away, then who knows what part of the code will be uncovered. But it's a key thing to keep in mind. Pipeline speed is key, and in the pipelines I'm working on, I try to keep it to 20 to 30 minutes max, from check-in of code to deployment to production, finished, end to end. So, deployments, as a last step, I'm going to share 2 deployment strategies which you can deliver you the necessary confidence to do it a lot. And the first one is called the Canary, based on a Canary feature in the mines, which hopefully died before you did, when there was a gas leak of some sort. The Canary in deployment serves much the same thing. Imagine we have the web and the load balancer, and we have a bunch of the same version of the service or application, if you will. This is all version 1.0 of our application. We have multiple machines serving that version of the application behind the load balancer. This is a situation a lot of you are familiar with, I assume. What we then do is essentially start the next version of the service, 1.1, on new machines or somewhere else, and they don't serve any traffic initially, 0%. And then we give a teeny little bit of traffic to those services, 1%, depending on how much traffic you get. It may be less or more. And that's our canary. We roll that traffic over the new version of the service and see whether everything works, whether we see elevated error rates or not, whether we see metrics going up or down, etc., etc. And when everything is okay, we start ramping up that traffic until we're at 100% for the new version. And then we can take the old version out of commission and delete it. It's a very interesting strategy. Another strategy is the rolling update, where we again have the load balancer with our application version 1, 3 times, 3 machines. And instead of adding the canary, we start service version 1.1 and let it boot, depending on what kind of application you have, how complicated it is to start. And then when it's started, we replace one of the 1.0 instances in the load balancer. And we verify, and if that all works out, then we do the same thing on the next instance, and we do the same thing on the third instance, at which point we've replaced everything. Both systems allow you to do zero downtime deployments. If you do this right, then nobody will know that service 1.0 was replaced by 1.1. And then the build pipeline could look a little like this. All the stages, this is Jenkins, but there's tons of alternatives, and they all offer more or less the same thing. At this point, it comes down to personal preference, I think. But this is a pipeline from a project I was on not too long ago. This is still 21 minutes. At this point, they've improved their speed to 12 minutes end to end. And this is on a large site. And if the pipeline breaks, it's important that people know about it. At one project that I was on, we had an actual siren, an LED lamp which would annoyingly flash and also make noises to alert people that their build pipeline was broken. Because if the build pipeline breaks, that's the thing that you have to deploy software to production. There are no manual deployments anymore. So the pipeline is your lifeline. So if that breaks, then fixing that becomes an important thing. So feedback to everybody that it breaks is a nice thing. It can also be an email, it can be a Slack message, as long as people see it and actually act on it. All right, so now we talked about deployment strategies, about testing strategies, about branching, about dealing with legacy. So I hope that now that you've heard all this, that you're completely capable of deploying on a Friday, every Friday, any Friday, not necessarily because you have to, but because you can. And like Borat, you can do it too. There's some more literature for you. If you want to read up, Continuous Delivery, the Bible, definitely get that. The Accelerate book, The Science of DevOps, is very interesting one. blowing us up out of the water are completely incomprehensible. Whichever you want. But I'll be here for a little bit to answer any questions that pop up. Thank you again.
Dankjewel Michiel. Namens de internjongens wil ik jou bedanken met een kleinigheidje.
Oh, dankjewel. Top.
Alsjeblieft.
Dank je.
En jij bedankt.
Oké, super.
De volgende meetup die staat gepland op 10 januari. Dat is Ode aan de Code nummer 9. En ik hoop dat jullie daar allemaal bij zijn. En neem gerust iemand mee. Bedankt.
Top.
Dank je.